Hello everyone, welcome to my channel. My name is Vinod and today we are going to discuss about the small oscillation. This is the third video on small oscillation. So let's start. So this is the thing you have to remember. You need to remember this thing if you want to solve the small oscillation questions. So the points here are, first point is that potential V of x will be given to you in the question. Point number 2, you have to do the first derivative of the potential and you have to take is equal to 0 to calculate the equilibrium point. So this is the point number 2. So why we are doing this? To calculate the equilibrium point, we are taking derivative 0. So as we know, very famous relation between force and potential. So suppose you have some system and if you want that system to be in equilibrium. So when the system will be in equilibrium, when the force, external force is 0, then your system will be in equilibrium. So if you want to calculate the equilibrium point, you have to take the dV by dx is equal to 0. So this is the point number 2. Point number 3 is that you have to take the double derivative. And double derivative we are doing for calculating the stable point and unstable point. Which point is stable, which point is unstable. And in such question, they will ask about angular frequency at stable point or unstable point, capital T at stable point, unstable point, and frequency or linear frequency. Okay, so let's take few questions related to this so we'll understand better. So this is the question number 1 and the question is, for a small oscillation, particle of mass m interact with a potential. Find out the angular frequency. So potential is given to you here. V of x is equal to ax square plus b upon x square. Now our next task is take the first derivative. So first derivative will be 2ax minus 2b upon x cube. And we'll take it 0 to get the equilibrium point. Now if we'll solve this, so 2ax is equal to 2b by x cube. And if you'll see here, 2 will be cancelled out. And if we'll simplify this equation, so x to the power 4 is equal to b by a. So you will get x is equal to plus and minus b by a to the power 1 by 4. Right. Now we want to calculate the angular frequency. So we need the double derivative of the potential. So t square v by dx square, that will be this. If we'll do the double derivative of this equation, it will be 2a and 6b upon x to the power 4. And now if we'll put x is equal to plus minus b by a to the power 1 by 4 in this equation, because this is the point, stable or unstable, this is the equilibrium point. If we'll put here, so t square v by dx square will be 2a plus 6b and x to the power 4 will be b by a. So here b is cancelled out. So what we will get? d square v upon dx square, we will get 8a. And omega, angular frequency, is the double derivative of the potential divided by m. So your omega will be 8a by m. And this will be in unit second inverse, right? Okay, so let's take the second question. So this is the question number 2. So for a small oscillation of mass m that interact with the potential this, find the angular frequency at stable point. So this is the important point. You have to find it at the stable point. So let's write our potential here. V of x is equal to x squared by 2 minus x to the power 3 by 3. So to calculate the equilibrium position, equilibrium point, we have to take the derivative. So this will be 2x by 2 minus 3x squared by 3 is equal to 0. So this 2 will cancel with 2, 3 will cancel with 3. So what you will get, x minus x square is equal to 0. If you will take x common, 1 minus x is equal to 0. So you will get x is equal to 0 and x is equal to 1. These are the two equilibrium points. So which point will be stable and which point will be unstable? For calculating that, we have to do the derivative because it is asking at the stable point. So we have to take the second derivative first, d square v by dx square. So we will get 1 minus 2x. Now the condition is d square v upon dx square. If it is greater than 0, then the point will be stable and minimum. Okay, and if d square v upon dx square is less than 0, then that point will be unstable point and the value will be maximum. Okay, so let's put here first x is equal to 0. So if we put x is equal to 0, so d square v by dx square will be 1. So it is coming positive, right? So this is the stable point, stable and minimum point. What? X is equal to 0. Now let's put x is equal to 1. If put x is equal to 1, so double derivative of the potential will be 1 minus 2. This will be minus 1. So this point is negative, right? It is what? Less than 0. So this point will be unstable and maximum. So we have to calculate the angular frequency at stable point. So what value will put? We'll calculate this thing for x is equal to 0. So if we'll take x is equal to 0 here in double derivative, so what you will get? If I'll take x is equal to 0 in double derivative, d square v by dx square, x is equal to 0, so I'll get 1. And it is asking about the omega. So omega is double derivative of potential divided by m. And double derivative of potential will be coming 1 at stable point x is equal to 0 divided by m. So this is your angular frequency. And unit of this will be second inverse. Okay. Now let's question number 3. Let's take question number 3. That will be similar to this question. So this is the question number 3. For a small oscillation, particle of mass m interact with this potential given to you and find out the angular frequency. Let's take this is also at stable point. Okay, so let me write first my potential V of x is equal to x to the power 4 by 4 minus x square by 2. Now I will take the first derivative. So what I will get? 4x cube by 4 minus 2x by 2. So these are cancelled out and that is equal to 0. So what I will get? I will get x cube minus x is equal to 0. Right? Now here if I'll see x is common, So I will get x square minus 1 is equal to 0. So what will be your points? Your points will be, if I simplify this, I can write x minus 1, x plus 1 is equal to 0. So what I will get? I will get x is equal to 0, x is equal to 1, and x is equal to minus 1. Now again I have to calculate the angular frequency at stable point. So I have to find out which point is stable point. So first what I have to do? I have to do the double derivative of the potential. So that is, if I will do the derivative of this one, so it will be 3x square minus 1, right? 3 square minus 1. Now if we will put x one by one, so suppose I am putting x is equal to 0, so d square v upon dx square, what you will get? If I will put 0, you will get minus 1, right? If I will put x is equal to 1, so d square v upon dx square, what you will get? If I will put 1, so this will be 3 minus 1, 2. Now if I will put x is equal to minus 1, so again you will get d square by dx square is equal to 2 because it is square. Okay, so next we have already discussed in last question, this is negative, right? So this point will be unstable point because d square dx square is less than 0. Now these two are positive, so these 2 points are stable point. Stable point. This is also a stable point. So our stable point is 1 and minus 1. Okay. Now we want to calculate the omega. So omega is what? Omega is double derivative of potential divided by m. So if I will put 3x square minus 1 here, 3x square minus 1 divided by m, and it is asked at a stable point, so stable point is 1 and minus 1. So if I will put both this value, so this will be 3 and 1, so 3 minus 1 divided by m. So you will get under root 2 by m. So your omega is here under root 2 by m. This is your answer, and unit will be second inverse. I hope these things will be clear now to you, and please like this video and share with your friend and subscribe this channel. And if you have any questions related to any questions, please email me on this email vrphysics21@gmail.com. And if you want to refer some books, please check out my link in the description so that it will be helpful for you. Thank you.